Hello, everyone. I hope you had all a great day. This is my first recording in English. You might ask why I'm doing this and why I'm recording in English. Uh, the main reason is that I want to improve my presentation in English and help me to be a better presenter. I think I had that problem even in my own language. I always had the fear of speaking in front of people. Now, when I'm living in other country and I have to do it in front of other peoples with different language, I felt that more than before. Uh, the idea comes to my mind a couple of months ago. I think no, it's 3 or 4 months ago. We were in a meeting to provide some engineering services to one company, which was it is an innovative company that wants to produce some members that we were responsible for the engineering design as a structural engineer. During the meeting, I tried to be very active. I tried to point out the problems, the difficulties that we may face, and ask questions. Did you consider blah blah? And I was active, and I was happy with myself. Okay, I'm engaging in the meeting and everything looks good. But in the end of the meeting, the owner of the company asked one simple question from me, and it was like a cold water on me. Uh, he just asked me, "Okay, Arash, tell me about yourself and your background." And at that time, Iranian shy character of me comes out. If as To be honest, if someone asked me that question even in Farsi, I cannot tell some positive things about myself. uh, I think I have that problem. I always underestimate myself, but at that time there was some awkward um, silence in the meeting, which was the main key of thinking about recording these type of videos. uh, I had a couple other reasons for myself to record these type of videos, and starting with this topic, which I'm going to tell you in next slide. But in the office, there are sometimes fresh graduate students comes to me and ask simple question from me, and at that time I feel that I try my best to give all I know and help them how to figure out their problems. But sometimes I feel that I also myself needs to go back in the books and learn. It's even it's simple, like, but still I need to refresh myself. That's the other reason that I choose these topics. So I know. Uh, uh, mm, During these recordings, I'm always trying to keep imagining that there is a lot of people in front of me. As I told before, I try to improve myself. I know I will make a lot of mistakes in the presentation, in even in pronunciation, or a stress of the words, or my main problem is grammar. Just bear with me. I try to improve myself, and that's it. Thank you so much. This is the first slide. It took 4 minutes to explain all these why I'm going to record, but I think it's you will understand from next videos that I'm going to publish. We don't have these explanations. Okay, let's go to the next slide. This is the first time that I'm using PowerPoint while I'm recording, so I'm still struggling and trying to learning how to work. I have a pen here. I don't know even how to. Okay, uh, I'm learning. So the topic that I picked for my first presentation is loads on structures. Why I picked this topic? Because uh, the main reason that when I was studying my bachelor degree, I don't know why, but the university removed this course from our syllabus. I only studied this course for a short time in 2016 or 17, I'm not sure the exact date. But when I was preparing myself for professional license exam in Iran, when I want to be a PE in Iran, I studied a little bit about loads and structures. We all know have some kind of sense about the loads, what kind of loads that we have, like dead load, live load, a snow load, wind load, seismic load, and all of the loads that you can see in the picture. But having a understanding how to consider it in your design, basically my main focus is in Canada and based on NBC. I thought that it would be double win for me while I'm trying to improve my presentation skill. Also, I help myself to learn about this topic. Uh, Now let's jump into the topics. There are four categories, different categories of loads and structures, like dead loads. We are consider these type of loads as a gravity load, like dead load, live load, a snow load, which is different in different environment, lateral loads, and these three are vertical load or gravity load, and these are lateral loads, which include earthquake or wind or even soil pressure load. Each of these load categories has different type of suggestion into the codes which we should follow, and uh, my main idea to get to know it based on the NBC, National Building Code of Canada. uh, there is one other question: why we want to calculate the loads. Basically, we design members based on the loads. I'm not gonna go to answer these simple questions. I just prepared the slides. You can read. The slide is pretty simple. uh, I want to be talk more. So why we calculate these loads? We want to design our members based on the most possible exact load that it's acting on our members. If the if we underestimate the load, the structures may become unsafe, and we overestimate the load, the structures becomes unnecessarily expensive, and is not optimized design as an engineer, which we should always consider the economical part of the problem in our design. Uh, Here's some explanation about the dead loads. Like, it's a permanent weight of the structure. Dead load is also has two categories, like dead load and super dead load. Dead load is normally we tell dead load as the weight of the member, the self weight of the member or elements, and the super dead load is the all the other dead load that, like furnitures, tile, ceiling, or stuff, or even walls, partitions, or any other type of dead loads that act on the structure. And that the most parameter about the dead load that it's predictable and always constant over the time. For example, when we consider the live load, we design based on that its probability problem. We consider that the chance of existing that amount of load based on the definition of the area for the live load. But for the dead load, this always exists, and it normally defined by the weight of the parameter and the building's code. Uh, my main focus is to calculate dead loads based on the material in Canada. So I prepared one dead load for metal deck floor for different deck type: 76 millimeter narrow rib floor and 76 millimeter narrow deep floor, and also uh, 76 millimeter wide rib floor. You see the different self weight of the deck, which is the narrow one is heavier, and this is the total kPa weight of the deck weight, and uh, the concrete volume for 60 millimeter topic. The amount of concrete volume for 6 millimeter topic is only 0.009 and the concrete weight, we know that 0.22. I think if we multiply, I need to my phone, I don't know, I don't want to minimize the recording, but 0.92 multiply 2.4, yeah. if you multiply if you multiply this value by 2.4, it will give you 2.2, which is the concrete weight including the 65 millimeter uh, 65 millimeter of concrete on top, and the total weight, which is include the weight of the deck plus the weight of the concrete on top, is 2.3 kPa. This is the weight that we consider in our calculations. Uh, there are some other factors which we should include in the dead load of the weights, like the mechanical or electrical equipment that we use under the ceiling. Normally we consider zero point 0.2 or 0.25 kPa for that as a dead load for the whole area. In some areas that there are very heavy and big mechanical equipment, we might use 0.5. I Let me look at my notes here. I don't want to miss something. This is the main idea of the dead load. Let's go to the next slide. Okay, in this slide talks about dead loads on finishes, which I mentioned in the previous one. For example, for the suspended tile ceiling, I remember I prepared picture for this. I prepared this PowerPoint last week. That's why I'm not completely aware of the whole slides. I just started to recording. I didn't go over once, but I know I prepared some picture. For example, suspended tile ceiling is the one that we use a lot in also in Iran, but we see a lot in Canada. If you go into the commercial building, you will see this type of ceiling. The first one on the left, I forgot to add some text or caption for each picture, but the first one on the top left is the oh, I cannot go to previous slide. Okay, I didn't know if I go to the next slide, I cannot go back to the previous one since I'm recording on PowerPoint. but I have my notes here. On the first picture on the top left corner is the suspended tile ceiling. For the suspended tile ceiling, the given value in the most codes is zero point 0.2 kPa. If we have that one, we add zero point 0.2 kPa plus our dead load calculated from the type of our roof types. If we have glass and plaster ceiling on the second picture on the center on the first row, that one is normally at uh, 0.4 kPa. This is the older type of construction. You might not see these type of construction today's, but if you face any, for example, repair or remodeling or rehabilitation old buildings, you might face these type of roofs, which the dead load is 0.4 kPa. This the gypsum board ceiling. The gypsum board is the bottom left. Is the most common use that we. This is the type of ceiling that we saw a lot in these days. Uh, I think in most buildings now is it's a gypsum board, which mm, pretty lightweight type of the ceiling. In calculation, for example, for 16 millimeter board, it's only 0.10 kPa added to the dead load of the roof. I will put the PowerPoint. I will make a PowerPoint as a PDF. There are some tables in the PDF that is very variable. I guess this is based on the all the dead loads that considered in the books or even the projects. I gathered all together into the tables and put it into the PowerPoint, so it might be useful in future, especially if you work in Canada. The third row of the fourth row of in the table is gypsum ceiling suspension, which is also no in the table. I have I'm sorry that you cannot see the table, but in I think when you're watching the video, you can pause and see the tables. You don't need my voices that much. You can I'm only uh, explaining the table rows. But there are two row in the table. One is only the gypsum board and ceiling. The other one with suspensions. It means, for example, for the first floors or in the lobby in the buildings, you need some kind of suspensions from the. This is like the suspension. You have the suspension structure, and that then install these gypsum boards, which also you need to add. You need to use point 25 kPa, 0.25 kPa. And for the tiled floor, which is a heavier type of flooring, it's only zero point 0 to 1 kPa add to as a super dead load, or in this picture it's just like a mosaic or terrazzo floor, which is a heavy. We should consider 2 point kPa. So I will write all the kPa that recommended in the table. In this one calls suspended tile ceiling, suspended tile ceiling. The dead load should be zero point 0.2 kPa. This is last is 0.4 kPa. Last and plaster. This is gypsum board is 0.1 kPa or 0.13 kPa. A difference if it has suspension, make it 2 kPa with suspension structure. This one is tiled floor, 1 kPa, and this one is terrazzo floor. It's just like a concrete, 2.4 kPa. This table is a partition load calculation. I made this table as some kind. I tried to make it as a flowchart, but it's very time consuming. So I made it as a table. Summarize and this table summarize how the partition loads are determined in NBC. Normally tells us we had the same in Iran. In National Building Code of Iran is also used 1 kPa as a dead load all over the area. This is the mostest and safest approach. Even now in NBC 2022, I will review the chart, but even now in NBC 2020, it allows us to decrease that value to half kPa. But there are a lot of different problems that will happen in the future, which I suggest still use 1 kPa when you want to design slabs or anything or floors. The main reason is that after 5 or 6 years, the client wants to add one heavy structure in his buildings or change the usage of the buildings, and even these small consideration when you're designing is going to helpful for the next engineer. Let's overview this table, how we can look at how we can use this table. The first is I consider when I was thinking that providing this table, I consider myself as the one asking the question. The first question that you should ask: are the partitions present or expected? Then what action that need to be required? Partition load must be included in the design, even if not installed yet. Then we go to the approach, what codes requirement. If you go before MB 96, the codes required 1.2 kPa. In NBC 2020, it make it point half, but it added some kind of if situations. Uh, for example, are partitions clearly shown and unlikely to move? If yes, calculate the actual load of the partitions, which is okay. It tells if you know the exact location of the partitions, and if you are sure that it's not going to move in the future service life of the building, you can calculate the exact load and add it in your structures. But still it's very hard and time consuming to add these type of loads. For example, you have 20 or 30 story building, and each building has different type of partitions with different alignment, with different layouts on the building on each floor or each story, and you have to add it as exactly at each story. It's very time consuming process. We would rather just consider 1 kPa on the whole area as the partition as a dead load. uh, Calculate the wall surface load. For example, in this table, I provided how to calculate the exact weight of the wall. If you want to do it exactly, for example, in a school, the example comes from the school. In the school, we know that the wall of the classroom is not going to be moved or changed for the during life of the structure. We have the dead load, we have the thickness of the wall, we have the length of the wall, we have the height of the wall, and by multiplying the number that we have by the height, we have the kPa, which we can add it on our floor design if we have a floor. So the steps is explaining for the gypsum wall in the table. For example, we have a gypsum wall, one kPa per side. So we have two side plus studs. Approximately a stud weight is 0.02. So the whole weight would be 2 multiplied by 0.1 kPa plus the start weights. This is the kPa weight, 0.25, that we should round. And when we want to convert this load to the floor load based on the wall heights and spacing, for example, uh, we can calculate, multiply by the wall height and calculate the loads that need to be as a linear load on a roof or on a floor mainly, not roof. But if we have cladding or heavy concrete pre-slab in our floor, we should consider those as a dead load in exact location, which we had the same one in our national building code. Oh, it's over 26 minutes. I had something less in my mind. I think there is only 5 slide remains. Uh, in this slide, it talks about the loads on mechanical and electrical services. Distributed loads such as ducts and wiring typically, for example, in here, ducts and wiring typically takes zero point 0.02 kPa, and sometimes we consider 0.25. Basically, what I'm doing for the partition load, 1 kPa on the whole area, if the weight of the partition is not heavy or is not a precast member or concrete cladding or something. For the mechanical and suspended, electrical and mechanical combined together, I used 0.25. This is pretty simple. Make your life easier. You don't have that much normally time to spend on figuring out exact value of the loads in your when you want to design a building. There is something that we have rooftop units in Canada, which is very common. Adding or changing the rooftop units normally is on the roof. Sometimes even in schools or other area, they after, for example, after 20-50 years, they decided to change the units. The new units normally is heavier. We have the same situation for calculating the slab of the elevator. I have at least 4 or 5 different projects that they want to change the elevator motor. We call it motor or engine, elevator engine, and the new engine is heavier, is built bigger, or the new rooftop units are bigger and heavier. Because of this, you need to predict this type when you calculating your load. It's better to have the safe margins when you're designing your buildings, because these are the mechanical parts. You are sure they are going to be damaged before the service life of your building, so you have to consider, for example, next 20 years the other technology might bring the type of rooftop units that is heavier, so you might consider that in your design. But for the large rooftop units, mechanical rooms, 2 kPa is a good number that we can use. Um Here's in this table also mentioned that if the weight of the equipment that if we are going to put on our roof is over 500 pound, it's better to consider put it at the exact location on the roof and design it based on 2 kPa. And that's it. You can read these tables. I try to prepare a reference where I get these number. All these number is value is, I can say, 80 or 85% is correct. I used from different codes like wood manuals or structural steel design manual, and I put this reference for that. What else I can talk about? Okay, one more thing that is very important. We always need to define a framing when we want to consider rooftop units on a floor. When we are using big rooftop units, we need to add reinforcement to the roof. Also, we need to consider snow drift scenarios or cases, case 1, case 2, case 3 for big rooftop units, which for the snow loads I think it would be in our next recording videos. Now I want to talk about dead loads for green roof. We didn't have any green roofs in Iran. We had or maybe in some buildings in Tehran, but the roof garden is different with green roofs. The green roof, the plants or structure will grow, and the weight increase during the life of the building, and which you should follow the recommendation in the code. I don't want to talk about that much, but normally the, you have some kind of increase in the weight for the service life. Um, okay. Uh, I didn't expect. We can talk about. Let's finish this. Only two slide remains. For the live loads, most of the codes and standards have some kind of recommendation for the live loads. But what is this recommendation? It's based on the occupancy on the building. For example, in National Building Code of Canada defines assembly occupancy and non-assembly area, assembly area, non-assembly area, and for each of these areas it recommended some type of live load to consider. What is assembly area? Area which where people gather in large number. You For these areas, normally we consider 4.8 kPa. You can see in the slide that 4.8 kPa. For the large mechanical room, 3.6 kPa. My picture is on the right corner. I don't know. For library, 7 kPa. Let's make sure. Yeah, for the library and storage of the books, 7.2 kPa as a live load, which is a very big number. For the office area, 2.4 kPa. Or live room in the buildings, 2 kPa, which is similar to what we had in Iran. These spaces as a assembly occupancy examples, these spaces can experience dense crowd loading. For this reason, they are classified as assembly occupancy and generally required live load as 4.8 kPa. City halls, House of Parliaments, airports, especially transit and public areas, church, mosque, hotel, classroom, and every area that you think that people is going to be gathered together. These are the definition of the assembly and occupancy examples, which you can find more information in the NBC 2025, I think, but there is no different. These areas in the next slide that we can see is not assembly area, and this is the final slide. Finally, uh, what is non-assembly area? Offices, areas, manufacturers area, retail stores, shopping malls, residential areas, parking garage, storage room, hospitals, prisons, library stack rooms. Prisons is not also kitchens and toilets. These are not considered as an assembly area. So when it's not an assembly area, we can use it. There is a live load table in the NBC or OBC, or even, for example, uh, code number 6 or mapase shish in Iran, that we can use different type of the live loads from the table. You can use this table as your main numbers that we need to calculate. Thank you so much. I know I made, if I listen again to these slides, I might have some mistakes in pronunciation or usage of the words or grammar. I appreciate if you like or give me some kind of energy to go more and deep. I'm trying to help myself, and your support would be a boost to me to follow this path. Thank you so much. In the next video, I'm going to talk about a little bit about live load and jump into the snow load. Maybe talk about live load reduction calculation. Uh, Also, maybe I bring one or two example about the calculation of the live loads, and then start to explain the snow load, which is very important in Canada. Thank you so much.